In this video, I'm going to discuss Newton's third law of motion. It states every action has an equal and opposite reaction. If you ask anybody who has had some exposure to science or physics about Newton's third law of motion, the person will be able to easily recall it. Maybe because the statement sounds more like a quote or a proverb. Every action has an equal and opposite reaction. In this video, we're going to look at Newton's third law of motion in depth and try to really understand what it is all about. Let me begin with a very simple example. Let us say this is a playground, right? And let us say this is a football, and this is a footballer kicking the football. This is the foot of the footballer. He kicks the football. The ball starts moving along the ground or starts flying off. The question we have is, what is the action? And the second question I have is, what is the reaction? Of course, I'm talking with reference to Newton's third law because it talks about equal and opposite reaction. So we should be clear about what is action, and what is the action and what is the reaction. Okay, what is the action? I'm sure you have got it. The action is the footballer hitting the ball, or the footballer applying a force on the ball. Right? That's the action. What is the reaction? Now, if to this question your answer is the ball flying off is the reaction, then we need to discuss this law more in detail. But if your answer to this question, what is the reaction, is the ball also applies an equal and opposite force onto the foot, then you have a good understanding of Newton's third law of motion. Yes, the reaction is the ball also applies an equal and opposite force onto the football. So the ball applying a force or hitting the footballer is the reaction. This is what Newton's third law is all about. It says that the foot applies a force on the ball also applies a force onto the foot. If I want to represent it in terms of symbols, this is what I'll do. Force applied by the footballer onto the ball is equal to force applied by the ball onto the footballer. Okay? Of course, these are vector quantities, so I will show an arrow and I'll put a minus sign over here because the foot is applying a force onto the ball in this direction, whereas the ball is applying a force in this direction. So they are in opposite direction, therefore this minus sign. So this is the mathematical representation of Newton's third law of motion. In this video, we are not going to worry about the direction. We are not going to look at these forces as vector quantities, even though they are. We are simply going to focus on the magnitude. And therefore, I'll rewrite this as force applied by the footballer onto the ball is equal to force applied by the ball onto the footballer. As far as this force is concerned, footballer applying a force on the ball, we are able to visualize it because we are able to see the effect of this force. We see the ball moving. As far as this force is concerned, the force applied by the ball onto the footballer, we find it difficult to visualize this force. Reason? Because we are not able to see the effect of this force. The ball is applying a force onto the footballer, but the footballer is not moving. There is no effect, or there is no observed effect of the ball onto the foot. Hence, it's difficult to visualize this force. What I'll do is I'll use Newton's second law of motion to understand this. Newton's second law of motion says force is equal to mass into acceleration. Right? So if I use this over here, the force applied by the foot on the ball will be equal to mass of the ball into acceleration of the ball. And the force applied by the ball onto the football would be equal to, or the footballer rather, is mass of the footballer into acceleration of the footballer. Now, if I look at this equation closely, what I can see is mass of the ball is very, very small as compared to mass of the footballer. This is very small, this is very large. Therefore, quite obviously, acceleration of the ball will be very, very large as compared to acceleration of the footballer. I hope you get this math. Still, I'll take an example and try to explain that. Let us say 2 into 50 is equal to if I take a smaller, now 2 into 50 would be 100. If instead of 1 I take 1, instead of 2 I take 1, then I will have to multiply it with 100. So if this number decreases from 2 to 1, this number would increase from 50 to 100. Conversely, if I increase this number, 2 into 50, instead of 2, I take 25. So I have increased this, then the corresponding number for this would decrease. This would be 25 into 4. As I keep on increasing this number, this decreases. Conversely, if I decrease this number, for example, if I take 2 into 50 and I take this as half, from 2 I make it very, very small, then this number would become 200. So if this MB is very, very small as compared to MF, then AB has to be very, very large as compared to M. And that is what we see. We see the ball flying off, we see the ball accelerating, whereas we don't see the footballer accelerating. The reason is because it has got a very large mass. Right? I hope this has helped you understand Newton's third law of motion to some extent. I'll take one more example to help you understand it better. The next example that I'm going to take is, let us say this is a floor of a room, and let us say this is a wall. This is a wall. And let us say there's a person standing over here, right? And for some reason, I don't know the reason, he's applying a force onto the wall. Right? This is the wall, and he's trying to push this wall. Right? If I again use the equation that I used in the previous case, I'll write down force applied by this man onto the wall is equal to force applied by a wall onto the man. Of course, these are vector quantities, but we are ignoring them as of now. So force applied by man on wall is equal to force applied by wall on the man. Man on the wall, and here wall on the man. This I can write as mass of the wall into acceleration of the wall is equal to mass of the man into acceleration of the man. In this case, mass of wall is very, very, very large as compared to mass of the man. Right? If that is the case, if the mass of the ball is very, very large, and if now mass of the person is very, very small as compared to the wall, what we should see is we should see this man going back, or the man flying off, or the man rolling down along this particular floor. Or at least we should be able to see this man moving in the backward direction. Do we see something of that sort? No. We see the man still is standing over here. What is the reason? Does this particular case contradict the previous case? No, that is not the situation. Let me explain. What is happening is over here is when this person applies a force onto the wall also applies an equal and opposite force. Right? But still he does not move. Right? Maybe I'll ask you a question, and that will help you understand this better. The question that I have is, what would happen if the man was on roller skates? I think you got the answer. If he's on roller skates, right? If he's on roller skates over here and he pushes the wall, you will immediately see the man going back. So what's happening over here? This is what is happening. If I take these as the feet of this person, when he's applying a force onto the wall over here, right? There is an action-reaction pair here or here, but at the same time, there is an action-reaction pair acting between the foot of the person and the ground. The foot is applying a force onto the ground is also applying an equal and opposite force on this. And that is because of friction. So there is a frictional force existing between the foot and the ground. And this prevents this man from going back. The moment he is on roller skates, this particular force ceases to exist. Or it decreases to a very, very large extent. And therefore you see the person going back. So if the man is on roller skates, the friction force decreases, you see the man going off. So this is what is happening in this particular case. Okay, I hope these two examples have helped you understand Newton's third law of motion better. I'll end this video by suggesting or recommending a small change in the way we write Newton's third law of motion. This is how I would write Newton's third law of motion. Every action force has an equal and opposite reaction force. So instead of simply writing every action has got an equal and opposite reaction, right? What I would prefer to write is every action force has an equal and opposite reaction force, because that's what Newton's third law talks about. It says FAB is equal to FPA. It is talking about two forces, right? So Over here we mention action force. This is the action force, and the reaction force is this. They are equal and opposite. Right? Sometimes what happens, if you use the word action and reaction, they can be misleading. We think of reaction as, in the case of the footballer, we felt the reaction was the ball flying off. That is not what Newton's third law talks about. It talks about the coexistence of two forces in opposite direction. And this is how I would prefer to write Newton's third law of motion. Thank you.